Okay, so today we're going to continue on with part 3 of quality improvements. And we need to go down to here. Okay, so difference between quality control and quality assurance. Quality control involves measuring quality performance and compare it with specs. Quality assurance, on the other hand, is a management function. It's establishing specs, utilizing supplier capability to provide accurate quality, quality control processes, and that means for measuring. Quality management, which is also quality assurance, it's a function of planning, organizing, controlling, and improving the quality of products and processes. And meeting customer needs, one important determinant of how well a company satisfies its customers. Customers can be internal or external, and customers are often also called end users. Customer satisfaction surveys and focus groups are used to determine their level of satisfaction. Now I want to kind of change gears and go into receiving inspection acceptance testing. In automotive, we use the PPAP process for this. But it's the formal acceptance of a new or changed product, process, or system. So sampling techniques usually used in receiving inspection. It uses statistical sampling to determine whether to accept or reject a lot of material. And the lot is accepted if the number of defects falls below the statistically acceptable number, otherwise the whole lot is rejected. Controversial, but it can be useful in some circumstances when you're dealing with new or unproven suppliers, during startups, or building new products, with extremely sensitive products and products that can be spoiled during shipment, and with suppliers that have known production problems. So there's a thing called producers and consumers risks. If you study statistics, it's known better by its names, alpha and beta risk. So the producer's risk is associated with rejecting a lot of materials that has good quality or rejecting a true null hypothesis. And the consumer's risk, on the other hand, is the risk associated with purchasing material that has poor quality or accepting a false null. And that's the beta. So producer's risk is alpha, consumer's risk is beta. The goal of acceptance sampling is to reduce the producer's risk to low levels while maintaining the consumer's risk at acceptable levels. And the assignment of AQL, LTP, alpha and beta is a management decision. Once the value is determined for N, then it can be determined where N is the sample size and C is the maximum number of defective pieces. It's all a bunch of stats, but usually alpha is set at 5 or 10%, and beta is usually at like 10%. So take a sample of 20 parts. If 2 or more are found defective, then you reject the entire lot. And this is a YouTube on how to do acceptance sampling if you got more interest. Benchmarking. Several types are found in quality literature and are defined below. So you got process benchmarking, you got financial benchmarking, you got performance. So process and performance are closely related, but process is business process against internal or external standards, most often another company. How efficient are you with the process? And performance has more to do with cost structures, various types of productivity, speed of concept to market, and quality measures. Product benchmarking is kind of another one that's similarly related, performed by many companies when designing new products or upgrades to current products. This type of benchmarking often includes reverse engineering to understand strengths and weaknesses of their design. So you lay out a bunch of competitors' parts that you've kind of torn apart and reverse engineered and see who has the best ideas. Strategic benchmarking involves how others compete. This is rarely industry specific and targets companies that have usually won things like Baldrige Awards, Deming trophies, etc. And then there's functional benchmarking. Example would be ISM networking of purchasing professionals. It's comparing the purchasing company A to the purchasing department of company B. Here's a case study if you're interested on benchmarking. And then we're going to shift to the corrective action process. And the one we're going to look at is called the 8D, or the 8 disciplines model. It's a problem-solving approach. Here's a YouTube video on 8D. That's if you're interested in knowing more. And this here is an 8D form that is used. It's in Word, so you can edit it. And the 8D process, so has 8 steps. First step is form the team. Second step is to describe the problem. Use things like the 5 W's, affinity diagrams, 5 Y's. Determine an interim containment plan and permanent corrective action plan. Or until, so you want to do a containment plan until you have your permanent corrective action plan ready. Oops. And then determine, identify, and verify root causes and escape points. Also identify why the problem was not noticed at the time it occurred. So 5 Y's and fishbone help there. And then step 5 is to choose and verify permanent corrections. And step 6, implement and verify the corrective actions. So what you're trying to do in step 6 is confirm that the corrective actions you're implementing actually fix the root cause of the problem. Use a FMEA and other mitigation efforts and Six Sigma sampling and all this other good kinds of stuff here. And then 7 is take preventative measures, follow up to prevent reoccurrence. And 8 is congratulate your team. And then this is a corrective action plan you can use. So, I don't know, I think this is ISM, somebody. And that's the 8D. So then we're going to cover some other quality process, Six Sigma. This is packaging of quality tools and philosophies to provide repeatability to quality improvements. It's all about variation reduction. Much more cost reduction oriented than traditional continuous improvements organized around champions and belts. Follows this Y is a function of X, where Y is the dependent variable, which is a function of X, which is the independent variable. Output is a function of input and processes. So Y is the output, key business objectives and measures. F is the function, which is the interrelationships to be controlled and managed. And X is controllable and non-controllable variables that affect Y. Then there's Lean Six Sigma, which uses the DMAIC procedures to improve quality. This comes from Six Sigma, the DMAIC, define, measure, analyze, improve, control. And then Lean Six Sigma, what you're looking at is customers' critical to quality needs. You need to know what those are. You need a value stream map to understand the process. You need to identify non-value added efforts. This is all lean stuff. And then you get into Six Sigma stuff, which measures accurate, using accurate data, solutions to make improvements and implement solutions. So the first half is kind of lean, the second half is kind of Six Sigma. And then you've got just straight lean, which is refers to products, processes, or services contain little excess or waste. So a lean organization is one where lean thinking is applied to identify value-added activities and eliminate the non-value-added waste. There's 7 MUDAs and 7 types of waste. Inventory being one that is very common. Scrap. Weighting is another very common one. And then there's the Kaizen. So this is continuous improvement idea where organizations believe a process can be improved by numerous small improvements made over time. Then you got CP and Cpk, 2 purposes for performing process capability studies. What these CP and Cpk measure is the process you're using to manufacture the part or the finished good capable of meeting the specifications that engineering is given that it needs to perform to. So determine if the process consistently meets product specs and determine if it needs monitoring using process or SPC charts. So it helps managers understand whether the range is over which variation of process occurs as a result of the process or is natural random variation. And CP will tell you if the process is capable or if the variation of the process within the amount of variations allowed by the spec. Can you consistently meet your specifications? If your CP is greater than 1, then you can. If it's less than 1, then you can't. And CPK will tell you if the variation in the process is centered between your limits. So it could be that your process is capable, but it's more on closer to violating one of the limits than it is the other. So CP and CPK, this would be a CPK of 1 and a CP of 1. It can, you're just barely inside the limits, but it's within the limits, but it's very easy to go out here. This is CPK of 2, which is 6 sigma. You can park anywhere in here and you're not going to go outside the limits. Here's another YouTube video on CP and CPK if you're interested. We'll cover this in another session a little bit later. So you want your CP to be greater than 1. It's the specification range divided by the process range. So that's why you want greater than 1. If it's greater than 1, you have a capable process. It doesn't tell you whether the process is centered and whether it's a 6 sigma process, but it tells you the process is capable. CPK, on the other hand, will tell you whether it's a 6 sigma process and how capable it is. So you usually want a CPK of at least 1.33, which is 4 sigma. CPK of 2 is 6 sigma. This would be what you want to drive towards, 3.4 defects per million opportunities. And then you've got the PDCA cycle, plan, do, check, act. This is a YouTube video that goes over it. ASQ explanation down here. And basically it's plan consists of select the project, explain the reasons, set goals, prepare the action plan. Then you go into do, gather the data, analyze the facts, and develop the situation. And then check, test solutions, ensure goals are satisfied, implement solutions, and then act, monitor, continuous improvement. And then everybody's favorite, the 5S. Stands for sort, set in order, shine, standardize, sustain. YouTube video. There's some more information on 5S if you're interested, but it's sort or straighten, shine, standardize, sort, straighten, shine, standardize, and sustain. All right, supply manager evaluates 4 sources that provide the same product. The CPK values for each of these suppliers are as follows. Supplier manager wishes to achieve a 6 sigma level of quality. Given the situation, which of these suppliers should the supply manager select? So what is a Six Sigma level of CPK? Should be supplier D 2.0. The right question here. It is supplier D. All right, there's the summary of everything we covered in the whole module over the last 3 days. And now we got some questions out there. So we go ahead and get on them. There will be questions for E2. The last page, the last couple pages here. So we want to start with question 9 and go to question 14. Go ahead and get started on. Okay, if you're not done yet, you can just pause the video. But we're going to go over some answers here. Number 9 is alpha. Quality inspection should not be necessary. In other words, it is a non-value added process and can be eliminated. 10 is Charlie. Corrective action process determines the disposition of goods, but several options are available. 11 is alpha. Meeting with suppliers, senior management will provide RST supply management with opportunity to gauge suppliers' willingness and capabilities to improve quality and service. 12 is Charlie. Units completed per period are a measure of production performance, not quality performance. And 13 is Delta. CPK value of range 2 indicates Six Sigma. And 14 is Delta. Six Sigma is a process control system that allows no more than 3 defects per million opportunities. And that's what we have. We will cover tools in Excel tomorrow, and then CP and CPK later on. Talk to you later.